Hello, welcome to part 2 of Students with Learning Disabilities in Mathematics. My name is Stephanie Kidd and I'd like to welcome you to the Kentucky Valley Educational Co-op's The Holler. Today we're going to talk about the characteristics of a student with a learning disability in math. These characteristics that I will be discussing during this video are translating information into mathematical equations or expressions, poor reasoning skills, deficiencies in the areas of math, facts, and computational skills, and also solving multi-step equations. In this slide, we're going to talk about translating information into mathematical equations and expressions. Now, this is the frustration of the language aspect of math and terminology. Now, we know that this develops very young in students, that they may not know what's being asked of them, they may not understand how to translate what they're actually seeing into words. They have difficulty with following along with word problems and determining the steps needed to create an expression or an equation. Young students may not be able to explain what the information is that they read or is being read to them. They may have trouble seeing in their mind how the pieces would fit together, and they may only get caught up on the first part or the last part or the part that catches their interest in the word problem. So some things that we can do to help. First of all, we teach our students to chunk the information. We have students to draw the direction of the problem is going, or model that problem with counters or other manipulatives. We frequently ask our students to tell what they think the problem is about. This is great with the 3 reads problem, where you just read it for information and you ask the students, what's it about? And then the second time you read it through and you put the question to it, and at that point you ask them to, how does that information revolve around that question? And then the third time you read it to solve. So that's another way that they can do that. Have the students explain the problem to a partner. Teach them to self-verbalize as they go through the problem, asking themselves what information they need or don't need or where the problem's going. Slow down the delivery of the information so that they have time to break the problem up. Also, have a graphic organizer where they can organize the information. Research shows that students who have the ability to verbally describe attributes or characteristics of any type of math, whether it's graphs, tables, functions, all those things, they're more successful. So we want our students to verbally tell what's going on in the problem, they need to verbalize all the information around them mathematically that's there. So a lot of talking to partners, math talks, those kind of things need to be going on in the classroom. Sometimes we have to work backwards. So in a problem that we give them, we have them to tell a story about the problem and think about how it would be if they were working backward, or if they were unwrapping it, what would happen if they were unwrapping that problem. And then they may even use models when they're telling about the problem. That's important for them. Creating a comic strip to the problem can help the students sometimes. But construction is the big key to that. So build that problem, looking at the complexity of the problem, determining how they could do it differently. Those kind of things all need to be used when they're talking. But the biggest thing about this is having students talk and understanding the vocabulary about what's being asked of them in a problem. So the next area that we're going to talk about is poor reasoning skills. Reasoning is the ability to think logically and analytically. Analytical thinking is the ability to see things visually in the mind. A child that has good reasoning skills is able to see step by step, break down complex problems into more single or more manageable components. There's a difference between analytical and critical thinking. Analytical involves breaking down the information, whereas critical involves taking outside knowledge to evaluate the information. Students with good reasoning skills, they're able to determine questions and positions in different ways. They're able to reject information, verify information, test it, formulate it, and even draw a conclusion about a problem. But a student who has poor reasoning skills, they're not able to reflect on solutions. They don't know if it makes sense. They have difficulty seeing patterns and making inferences. They're not able to see elements in the problem that are most of the time, or even pay attention to details inside of a problem that's really obvious to others. So what can I do to help? Well, I'm going to ask them why they chose the process that they chose. Why did they feel that the information was important? I'm going to have them work with another student so that they can determine how they're reasoning through a problem. I'm going to teach them self-talk skills. I'm also going to do some self-talk with a problem myself so that they can start seeing the important information that I see in the problem. And then determine how that student attacks a problem. What's their approach to working out that problem? Do they see important information? Are they not getting certain things that they may need out of the problem? And then what is their understanding? That's a big thing for them. But most of all, maybe they can color coordinate things. They can look for certain things inside the problem that is important and highlight those. But those are just a few of the things that I can do for a child who has poor reasoning. The biggest thing is getting them to explain to me what they may need. With this section, we're talking about mathematical and computational deficiencies. With mathematical and computational deficiencies, we have concerns with students because they don't understand certain data. They have trouble determining things like how much, how fast, how frequently something happens. They have trouble with building precisely. Measurement is a huge problem for these students. Also, being able to predict, make suggestions. Their guessing abilities are not even close. When they look at data and make determinations, they can't see how those are correlating. They don't see patterns, and they have trouble with estimating, especially, like I said, in measurement. They just don't see the scale of the measurement. And what do they need? Well, they need number magnitudes. They need to understand relationships. They need operations. They need to link basic number sense to a quantity. They will have to have a lot of practice in this. They'll have to have continuous feedback. Things that you can do for younger students is finger counting, verbal counting, decomposing strategies, math, reasoning, and problem solving. But with students, older students, if you're doing measurements, talk about quantities a lot. Also, have them to practice measuring over and over again and making determinations on, do I measure that in inches? Do I measure that in feet? Do I measure that in miles? They'll need to do that often. There's multiple mnemonics that are out there for them to use. Those can also help with that. Have students to draw pictures. Teach them the 3-read strategy. Those are all things that they can do. Chunking the information inside the word problem. That's just a few of the things that they can do. I like using a graphic organizer for the student to organize the information, but help them correlate between the skills that they have and the skills that's needed for a multi-step word problem. Sometimes they just get bogged down because of the multiple steps, but let them see that I can break that down. Also, teach them the relationship among words in different situations. That really helps our students. I want to thank you for listening to this video, and thank you for loving our kids. So, we'll holler at you later.